Hi everyone, so today I'm going to be doing the elephant toothpaste experiment. This is one of the lab assignments that we are supposed to do for the fourth week of class. As always, I'm going to provide this explanation video and then show you the assignment. So for this experiment, I needed hydrogen peroxide, yeast, soap, warm water, food coloring, a plate, and a cup, and those are the materials that I utilized. So just a little bit of backstory on the experiment and trying to kind of put into perspective for everyone. Again, introducing it and explaining it before seeing it happen. One of the most important ingredients in this material, not ingredient, we're not making anything. One of the most important materials in this assignment is the hydrogen peroxide, which, as we know, has a chemical formula, H2O2. And this is important to note because as hydrogen peroxide breaks down, it turns into oxygen and water, which typically happens pretty slowly, but the yeast plays the role of a catalyst, which expedites the reaction. Yeast, something we all bake with, it's a pretty common microorganism, and it contains catalase, which actually acts as the catalyst to break down the hydrogen peroxide. And when it's exposed to oxygen, it helps break down naturally occurring hydrogen peroxide. So what does this mean? If you mix yeast with hydrogen peroxide, it's going to break down the hydrogen peroxide. And going from H2O2, it breaks this further down into water and oxygen gas. Oxygen gas will form the bubbles, and the bubbles would escape from the liquid and kind of move quickly. Adding the dish soap provides a barrier and surface tension, which allows the bubbles to get trapped. And this makes it more foamy rather than just bubbly. Now, that sounds bizarre because a lot of people compare foam to bubbles, but there's a difference. If you blow a bubble, it looks different than what foam looks like. So what we're expecting is a super foamy experience. I'm excited to find the right cup to use and see what it looks like. So as I stated, we'll be using hydrogen peroxide, and I'm going to be pouring that into an empty container, adding some dish soap and mixing that very gently. Food coloring, we'll see what color I pick, and then just mixing that all up. And then I'm going to be mixing the yeast with some warm water to activate it. You'll know when it's activated when it gets a little foamy, important to know. And then pouring that yeast mixture into the colored peroxide container. So this should be exciting. Like I said, just to kind of go over it one more time, the yeast allows the faster breakdown of the H2O2 hydrogen peroxide. And because oxygen is a gas, it wants to escape the liquid. And the dish soap helps trap these gases to make it almost more like, it actually looks almost like, when you have like a party popper and like that big like thing pops out? That's what it looks like. It makes sense in my head. If I can find a picture, I'll insert it. But yeah, so the reaction will continue as long as there's some yeast and peroxide left to feed off of each other. So I hope this explanation was clear. It's a little bit difficult to visualize, but I always like to introduce my videos with an explanation or show you guys the experiment and then explain it. I just think the explanation is the most important part. So I hope this was clear. I hope you guys enjoyed this, and thank you for watching. This is the dish soap, not food coloring. Now I'm going to take my food coloring, and since my dish soap is green, let's use more green. Actually, let me see if I have blue. I do have blue. Let's use blue. And the blue is empty, so we're going to go with green. So that's the green food coloring. I'm just going to squish this up a little bit. Close this. So this is just the peroxide, dish soap, and food coloring. So we got a nice green mixture over there. So next, I'm going to take 1 tablespoon of yeast. And I'm actually okay with if I use a little bit more of this than a tablespoon, but let's try to be exact. Let's see. I know you don't typically need a ton of yeast, but I also am more familiar with that when it comes to baking. Okay, so this is about a tablespoon, so I'm going to put that in there. Get it all off the spoon. Just even out that little layer. Okay. And now I'm going to take some warm water. I'm using my faucet water because why not? So my water is getting warmer. It's still a little bit room temperature, so I'm just going to let this get a little bit hotter. I don't want to burn myself because I don't want to deactivate the yeast. Okay, all right, this should be good. I'm going to take 3 tablespoons. 1. 2. My water gets super hot, so I'm trying to get like the right temperature. Let's see. Yeah, this should be good. Yeast actually always throws me off because my dad actually likes baking a lot, but he makes sourdough bread, so he makes yeast straight from the flour itself. So using like the Fleischmann's or like the packaged yeast always kind of messes me up a little bit, but let's see, and I don't want to over stir either, so I'm just going to stir a little bit gently for about 30 seconds. This might need actually a little bit more water. But it is bubbling, which is a good sign, so I really hope this experiment works. In my explanation video, I explained what's supposed to happen. And last week's video, my bottle rocket didn't work. But at the end of the video, I took it and I went to go pop the cap off, like what like 5th graders do in the schoolyard, like you pop it off and it goes boom. So I did that and it like exploded off and the whole bottle like completely changed shape. So it didn't work, but I think it worked. Okay, so I'm just gonna let this sit for an extra minute. I actually have the assignment pulled up on my phone if you see me looking over. Let's see. So I just want to keep this going a little bit. Okay. So I'm gonna try to do this in my sink because I feel like if it works, it could get super messy. But also that could be fun. Yeah. Let me grab a plate as well, just in case. Because I am filming this on my iPad, because if I take my phone, it'll look kind of distorted, and my iPad's easier to stand up. So I've accomplished all the steps. I'm hoping this works. I took the spoon out. You know, let me give it like an extra second. Okay. So here's my cup. And I really, really hope this works, because this looks so fun. Okay, the yeast is still active. It hasn't expired, which I think you can bake with expired yeast, but don't tell anybody I said that. Okay, we're going to give this a shot. Let's hope it works. Wow, that's pretty cool. That's pretty awesome. Wow. You see? Yum. This actually looks like a Shamrock Shake from McDonald's, which I'm a huge fan of. I need to touch it. Oh my god, it's so warm. That's so cool. Okay, wow. Wow, that's awesome. That's really, really cool. I probably shouldn't be touching it, but I had to. I'm a very sensory person, so I wanted to. That's really cool. Wow. My mom is a science teacher, so I might actually leave this on the counter for her to see it, and maybe she can do it with her students. She's a third, fourth, and fifth grade science teacher, but sometimes she'll ask me, she'll be like, oh, what are you working on? And like, she likes to show her students cool stuff, so I might leave this on the counter and show it to her. It's very pretty. I mean, come on. Alrighty, well, that's the experiment. I'm so happy it was successful. It looks literally identical to a McDonald's Shamrock Shake, which I'm a huge fan of. And it was super cool. So thank you for watching, and I hope you like my videos. Thank you.